Hi guys, and welcome to this class. And in this very video, we are going to be talking about the red blood cells. So mainly its production. So we can actually spend some more time talking about its lifespan, its destructions, and the like before we move into anemia. But mainly today we are going to be talking about the beginning of the red blood cell. Now, for you to understand the beginning of the red blood cell, you have to go back to the last class. We talked about the blood itself, and we said if you want to understand the blood, you have to know where it comes from. And then we said we have the component of blood. We said we have the white blood cell, the red blood cell, the platelets, and the plasma. So collectively, that is just the plasma and the blood cells. Now, we know where the plasma comes from. That is from the liver. And we said it is yellowish in color due to the effect of bilirubin in it. Cool. So we said the plasma is in the blood vessel, and then the white blood cell, red, and the what? And the platelets. They join in the journey and they start floating within it. Cool. Now, after that, if we have to pick these blood cells one after the other, we're starting from the red because I want us to deal with anemia firstly. So the point is, where do you think the red blood cells, where do you think they come from? The answer is very simple. Simply because I've told you, all blood cells come from where? From the hemocytoblast. So hemocytoblast is the one responsible for giving birth to what? The red blood cells. And enough with the introduction. Let's get straight up to the board and start illustrating and explaining things. So, I'll be right back. Yeah, welcome back. Now, talking about the red blood cells. So, the red blood cell. You see these guys? They are anatomically called erythrocytes. What? Erythrocyte. And the question is, why are they called that? Something. What's it? So the point is, eryth that you have right here actually means the red, and the what site means the cell. And remember, they belong to a component of the blood. So when they say erythrocytes, it literally means red blood cell. As simple as that. Now guys, the point is, where do these erythrocytes, where do they come from? It's actually from exactly the same place. And they are being produced. They are being what? They are being produced in a process called erythropoiesis. 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 When you see the word erythro, it's denoting the red blood cells. And the word poiesis that you have here means production. And that is what we'll be dealing with mainly today. So erythropoiesis simply means the production, or you say the formation of what? Of red blood cell. As simple as that. And now, if you really want to understand erythropoiesis, let me take you a little bit through something called homeostasis. You see, the reason why we used to have issues with understanding erythropoiesis is the fact that we do not understand that erythropoiesis is a type of homeostasis. Now, for you to understand this better, without even attending my homeostasis class, what is homeostasis? Forget about everything. Don't worry. Just give me a couple of minutes and you understand all these things perfectly. Now, imagine that someone is stabbed with a blade or with a sword or anything, and the blood started gushing out. The person is losing the blood, right? And if the person is losing the blood, if the person does not want to die, from the first illustration we made in this class of blood, we said the person is going to die if the blood keeps coming out. Then the body must trigger the production of more blood. So the amount of loss is going to be equal to the amount of the blood gain. And that is actually bringing a sense of balance. And that balance, restoration of that balance between the amount of blood lost and the amount of blood gained or produced again in your body is actually, can actually be referred to as homeostasis. We are trying to restore a balance. Now, the fact about red blood cells is that they can only live for 120 days. So somewhere thereabouts, 120 days. And then they are going to die. If they die, what happens? We have to replace them. And they are being replaced in a process called what? Erythropoiesis. Now, back to homeostasis. In anatomy, the topic is called homeostasis. 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 So, like I said, homeostasis is all about restoring balance. And under homeostasis, we have something called the feedback mechanism. The feedback what? The feedback mechanisms. And now, these two guys, forget about them for now. I'll come back big time and explain them and how they relate to what? To erythropoiesis. The thing I want you to pick from homeostasis is that mechanism or a mechanism will never occur without something in homeostasis. And that thing is called stimuli. What? Stimuli. And what is the meaning of that? I told you homeostasis is all about restoring balance. It means when something is going wrong in your body, homeostasis will not come in to balance it or to restore it without something telling it. And that thing is called stimuli. So stimuli means a change. So a change must occur in the body system before homeostasis can set in. Either something is going wrong in an aggravated way, that is, something is occurring, so that occurrence can be a change. Or something is reducing in your body, that thing can actually be a change as well. Now, if you do not understand that, forget about it. Let's try to synchronize rather, or to link, or to connect these two guys together. You see, erythropoiesis is actually a mechanism in the human body. It might be your first time hearing it, but that is just a fact. I'll explain to you very later. Now, if erythropoiesis is a what? Is a mechanism. And a mechanism will not start without the what? Without the change. Which means the production of red blood cell will not occur in our body unless there are some changes. So we can always start erythropoiesis from that stage. What are the things that can occur in your body to start the production of red blood cell? Now, they are not far-fetched. The stimuli for what? For erythropoiesis include 1. Reduction in oxygen level. Reduction in oxygen level. Why? You will understand very soon. Another reason, another thing, another stimulus, another change. Stimulus is singular. Stimuli is the plural. Making these changes now, actually. So the point is that, apart from reduction in oxygen level, another thing that can actually trigger the production of red blood cell in your body is reduction in the blood itself. Reduction in what? No, let's not use reduction in blood. Let's just say loss of blood. Aha. Maybe through hemorrhage or something. Loss of what? Loss of blood. So, loss of blood through hemorrhage. Follow these guys. So, loss of blood. And another thing you can actually use is destruction after 120 days. Destruction after what? 120 days. Destruction of these red blood cells. We can have a lot more of what? Of stimuli. But this is enough just for starters. Now, let's just talk about these three guys. How do you think they can lead to the what? To the production of red blood cells? Now, you have to understand the function of red blood cell in the blood. Remember we said the red blood cell, they're actually within the what? Within the blood vessel. Now, think of the red blood cell like a vehicle, a car. I call it a motor if you like. So the point is, there are some kind of what? Some kind of carriers in the blood. Their own responsibility is to carry things like gas molecules. So example is oxygen. That is the most important one. So they drive oxygen, CO2, and some other things. They drive them around back and forth inside the blood. Now the point is, if these guys are driving oxygen, for example now, if the oxygen reduces, something is going to change in the body. If you don't understand that, David, the next illustration is going to illuminate, or is going to what? Is going to make you understand this better. Now the point is that if you have a reduction in oxygen level in your body, what do you think will happen? Cool. Let's take a look at this now. We have someone right here. So we have someone right here. So we have the airways. So not to stress too much. Let's bring in the bronchi. Anatomically, this diagram is wrong, but I'm only using this for illustrative purpose. So now you know that normally this person should breathe in oxygen and take the oxygen down here way. The oxygen is coming straight up into the what? Into the lungs. Same thing is occurring here. Oxygen. And before you know it, we have lots and lots of oxygen molecules inside the what? Inside the lungs. Now, you see, the point is this oxygen, the next place they are going to is the bloodstream. The blood what? The bloodstream. So the oxygen will go from the lungs into the what? Into the bloodstream. So they will go there in numbers. And after that, this guy will find their way back into the what? Into the human's heart. So the oxygen will go into the what? Into the human's heart. So the The oxygen comes straight up into the what? Into the woman's heart. Now, no special details. So all these are just for illustrative purpose. So the oxygen will go into the what? The oxygen will go into the human's heart. And from the human's heart, the point is, they're going to get pumped into what? Into different body tissues. So they get pumped into the blood. So into the aorta generally. And aorta is going to distribute oxygen to different parts of your body. Now, you see, this oxygen, they are not just moving on their own. There are some people, there are some vehicles driving them. And the vehicle driving them is the what? Is the red blood cells. The point is, as they are jumping into the bloodstream, so the vehicle carrying them are the what? The red blood cells. The vehicles doing what? Doing their transportation, driving them, the vehicles moving them, is the what? Is the red blood cell. Now take that green mark as the what? As the red blood cell. So they are the one driving the what? They are the one driving this oxygen, the red blood cells. Now, you understand what I'm trying to do right here now. So, if this guy are the one responsible for us for driving oxygen all around, the point about this reduction in oxygen level, if there is a reduction in oxygen level now, do you think these red blood cells, do you think they will perform their function? Obviously not. So I apologize guys, I was distracted by something. So, the point is that whenever there is a reduction in oxygen level, or you lose some kind of blood, or there is a destruction of your red blood cells after 120 days, some certain things will happen. But before that, physiologically speaking, what happens in our body when it comes to oxygen and red blood cells? So, when you breathe in oxygen, you take it down into your airway and then into the lungs. From the lungs, the blood diffused into the what? Into the blood. Why inside the blood? It is the red blood cells that collected the oxygen from the what? From the lungs. So, they took it as a vehicle, so they drive it to the what? To the heart. And from the heart, straight up into the what? Into the aorta. Now, what is happening there? We really do not need it. But the point is that the oxygen is going to be saturated, going to be sent, distributed, so to what? To different body organs. Now, I want you to take note of two organs. The first one is called the kidney. So, the kidney. And the second one is the liver. Now, we'll be talking about them, but the point is we do not have enough page to tell you what I really want to understand from here. So I will wrap the board, start all over again with this diagram alone, and talk about how these three guys can be a stimuli for erythropoiesis. So, I'll be right back. Yeah, welcome back. Now, just for a quick recap, we said erythropoiesis is the production of red blood cells, and it is a kind of mechanism. And for every mechanism, there must be a what? A stimulus or stimuli. Now, the point is, we said reduction in oxygen level can actually cause what? Can actually trigger erythropoiesis. And not only that, we said loss of blood, loss of what? Loss of blood can trigger erythropoiesis, or destruction of red blood cells after 120 days. After what? 120 days. Now guys, you understand the fact from the last video that when you take in oxygen, it goes into the airway and then it is going to be collected into your lungs. And then a kind of blood capillary will take it out, take it to the heart, and the heart will distribute it to the general body system. Now, let's quickly come back with that small diagram. So, now, let's zoom that we have someone right here. Now, okay, so we have the airway, excuse me, so we have the airway right here. Now the lungs, cool. Now we said, when you take in oxygen, guys, it goes through the nostrils, so down the airway, and it goes into the what? It goes into the lungs. Oxygen. Now we said the kind of blood vessel, we're taking the oxygen away from the what? We're taking away the oxygen from the lungs. Oxygen from the lungs. And we said the person responsible for receiving this oxygen from the lung are the what? The red blood cells. So we use this as a vehicle, just like a car that drives them, take them out, and take them somewhere else. Now the point is, they are being driven to the what? Into that organ that pumps, which is heart. So the heart. And now, once they are being driven down into the what? Into the heart. Once inside the heart, they are going to be what? They are going to be pumped out through the aorta. And now the point is that this is not a real diagram of the aorta. This is just an illustrative diagram like I used to see. So if we want to make it look real, we can actually start from the heart, right here. So I'll be dividing the board, but I want to believe you understand everything that happens right here. Taking oxygen, RBC, the red blood cells, so they drive it straight up into the heart, and then they pump it out as well. So they pump the oxygen out, and the oxygen keeps going, and it keeps going and going and going. Now the point is that if this is our aorta now, coming from the what? Coming from the left side of the heart, right from here now. And the aorta keeps coming down. So if it keeps coming down like this, it's going to have some kind of connection with some organs. One of them is the kidney. Kidney right here. So we have another kidney right here. And around here we have the big organ called the liver. So we have the liver right here now. So we have the liver right here. So guys, you see, let's assume that this person is not having adequate oxygen. So let's assume this person is to breathe in 100 molecules of oxygen. But now this person is breathing in 50, for example. So there's a reduction in the amount of what? Oxygen intake. And since there's a reduction in the amount of oxygen intake, the amount of oxygen you have in the lungs is going to be what? Is going to be reduced. And because of that, the RBC are not going to be carrying an adequate amount of oxygen. They are going to be carrying a what? A reduced level of oxygen. Reduction in the amount of oxygen reaching the heart is going to occur. And the point is, the oxygen within this place are going to be what? They are going to be low as well. So, the amount of oxygen in the blood is going to be what? Is going to be decreased. But the point is, when the blood is flowing to the liver, we have some cells in the liver. Some what? Some cells in the liver. So normally you can term them as a hepatocyte, but I do not want to disturb you so much. But not only that, at the proximal convoluted tubules of the nephron that are inside the what? Inside the kidney. You don't have to know whether it is in the proximal convoluted tubule. Just know that the cells of the kidney has some cells as well. And these cells, their responsibility is to detect the level of oxygen. These cells of the liver and the cells of the kidney, their responsibility is to do what? Is to detect the what? The level of oxygen in the blood, whether it is high or low. And now, this is the point. If someone has a reduction in the level of oxygen, just like no oxygen or reduction in oxygen, the point is the amount of oxygen in the blood is going to be what? Is going to be reduced. And when the blood gets to things like the liver and kidney, these cells that are right here, they are going to detect that there is a reduction in what? In the level of oxygen. Now the point is, when they realize that there is a reduction in the level of oxygen, these cells will start releasing some kind of chemical. And that chemical is called erythropoietin. Erythro what? Poietin. So, let me change the marker. Let me use black. So I'm writing exactly the same thing. I'm just afraid it is not going to be clear. Erythropoietin. So, these guys, the kidney cells and the liver cells, they are going to release an enzyme, an hormone called the what? Erythropoietin. Now, what is this erythropoietin going to do? Erythropoietin is going to be directed to that what? To that cell that is inside the what? That is inside the bone marrow. So, that cell is called the what? It's called the hemocytoblast. Hemo what? Hemocytoblast. Beautiful. So, it is the erythropoietin that will tell the hemocytoblast to divide to form new cells. But the point is, which type of cell is it going to form? It is going to form either of the two cells. I told you we have the myeloid and the what? And the lymphoid. So the hemocytoblast will divide something called the myeloid stem cells. From the myeloid stem cell, start dividing until it forms a red blood cell. We'll go through the stages too. But right from this, we can explain the loss of blood as well. The point is, if this person is injured and he has a reason to lose a lot of blood to the external environment, it means if this person has 100 red blood cells, as in red blood cells, apologies guys, if this individual has 100 red blood cells in his body, responsible for carrying the 100 molecules of what of oxygen that this person is breathing in, if this person loses blood, it's going to drop to like 50, which means the oxygen carrying capacity is still going to be 50 now instead of 100. And if the oxygen carrying capacity is low, the amount of oxygen getting to the heart is going to be low as well. For you to understand the illustration I just made, the point is, we have 10 people who used to collect 10 bags of rice from a vehicle, and they take it into a shop. Now, that is their total number. 10 people take 10 bags of rice and drops it into a shop. Now, the day those people carrying that bag of rice reduces to 5, the quantity of the rice that will be entering the shop will reduce. So those people carrying the bag of rice, they are the red blood cells, the red blood cell rather, which is 100 according to our own assumption, just to understand. And now they are taking 100 oxygen only. But then, this person loses blood to the external environment. Red blood cells is going to be wasted. And the point is their number is going to reduce. And when their number reduces, the amount of oxygen they are taking will reduce as well. And when it reduces, when the blood is flowing through the body, these guys, the cells of the liver and the kidney, will note that there's a reduction in the oxygen we have here. And what are they going to do? They start releasing the erythropoietin. That is stimulating the hematopoietic to form what? Myeloid stem cells. As simple as that. Now, what about the last one? Destruction of what? Of red blood cell. The fact is, if the red blood cells are destroyed after 120 days, that is their lifespan. So, they live around 120 days, a little bit ahead or a little bit below. So the point is, after 120 days when they die, the amount of oxygen lying freely in the blood will be so high, with no one to carry them. And these guys are going to what? They are going to notice that. And they will send impulse through their what? Erythropoietin to the cytoblast to start producing what now? Myeloid stem cell. As simple as that, guys. Now, what else are you supposed to know right from here? I think by now you would have noticed that where we started from, which is erythropoiesis, which is the production of red blood cell, it has already started. And it starts with either one of these three stimuli. We have more than that actually. But the point is, whenever you're discussing erythropoiesis, you can always start by telling us it's a kind of mechanism. And the stimuli or the changes that can occur to bring about the existence or occurrence or happening of this mechanism is a reduction in oxygen level, loss of blood, destruction of red blood cells after 120 days. And all this series of events will lead to reduction in the amount of oxygen carrying capacity. And these cells are going to detect that. Point is, these cells in the kidney, from the kidney and the liver, they will detect all these changes. And then they secrete something called erythropoietin. And the erythropoietin is going to act on the hemocytoblast, telling it to produce what? To produce a myeloid stem cell. So therefore, erythropoiesis begin. Erythropoiesis begin. As simple as that, guys. Now, what are we supposed to discuss? After talking about the fact that it is stimulated by all these things, the next thing we are meant to talk about are the stages and the what? The stages and the materials needed for erythropoiesis. Now, without wasting time, I'll rub the board and get started with it. So, I'll be right back.